Hello everyone, good afternoon. Welcome to the class ECE341, the probability and stochastic process. Actually today is the last lecture. We will have a review for the whole semester. Then next week I will use the lecture time for questions. You will review for the final, and if you have any question, just come to the class Zoom meeting. I will have a Zoom meeting. Alright. Okay, today let's go to ECE341, the 14th week, Friday's class. This is last class with lectures, and today's lecture is for the review. It's a review for the final exam, the final. Alright. Of course, firstly, what is final? When is the final exam? There will be on Monday, 8 o'clock to 10 o'clock in the morning. The Monday, there will be May 3rd. Right, May 3rd, the first day of the final week. And we have 30 more minutes for you submit your visa, right? First submit your paper to the platform. And then the coverage, they cover the whole semester. Cover the whole semester. Totally will be 6 problems. 6 problems. Right, we have 2 hours. It's longer than midterm, and the problem is also more. We have six problems. And for the prepare, I still suggest you to prepare a formula sheet. Yeah, you still need a formula sheet, right? Remember in the first and second midterm, I mentioned that you'd better have a formula sheet before the exam to write down the important topic in some, just a few papers, right? Not, you don't need to check like all the textbook or check everywhere to find the important things. Okay, and then review. Here I just give the review for the last part. For the first and second part in the midterm, we already gave the review, right? Midterm 1 and 2 we have reviewed. And we have reviewed. Check the review for midterm 1 and 2 for those parts. And today I gave the last part. Give the review for the last part. Review for the last part. That is actually we have 2 parts. One is statistics. The other will be random process, right? Stochastic process. The first is statistics. The main topic is we try to find some useful information from sample values. Sample values. You take sample, then try to find some useful information, like some parameters that depend, right? Depending on the problem. So we start from, like we have a random variable x, and we have some values, some samples, x1, x2, until some xn. They are samples. symbols of x. Symbols of x. Of course, these symbols, they are also random variables. They are same random variables with x, and we suppose they are independent of each other. So we have name here. We call these as independent symbol trail of x, and we also call this as an IID sequence process. Yeah, if we use later use the process, I can say this is a ID process. ID is a independent identically distribution. Okay. So we have first one, we have the point estimation. Okay. Point estimation, that means we estimate the value, estimate the parameter. Estimate parameter. This is estimation is a theta hat, and the parameter is a theta. We want theta hat close to theta, right? And we have method, several methods. Actually, I introduced two methods, right? The first one is just the moment method. Moment method, and the second one is modified moment method. We have two methods. Actually, there are some more methods for the point estimation, but here I just introduced these two. You can go to the material. I post it in. You go to the material. Every lecture, I have some notes, some material, some papers. You read those, then you can know the detail about them. All right. Here I just want to mention, like estimate one parameter. Use EX equal to mean the average value. This is the mean of n symbols of x. Right? This one is defined as the n. Here is x1 plus until xn. Right? It's defined by this. Use this one. And this E of x is calculated by formulas. So that parameter will be a part of this EX. And M and X start from the given observed symbols. So this is a value you can have, right? You can calculate. You observed, then you plug in here, you can have this value. So this value can be obtained by the observation. And this is obtained from formula with a parameter inside. Then you can solve to find the parameter. So if you just estimate one, and okay, maybe it doesn't work. For example, EX do not contain the parameter you want to estimate it. Then you need to use EX squared. Right? Yeah, but in most cases, EX is enough. Just one parameter to estimate two parameters. Then you need to use EX equal to M and X, and EX square equal to M and X square. So this is the moment method. And this is moment method. Or EX equal to M and X, and EX squared is also not EX squared. We use variance of X equal to, you can combine. That will be the same way. We have another way. This is a, I would say, and here's a summation of xi minus the mean of n samples of x. This one. Yeah, this one. This is also a moment method. So these two methods, this one and this one, they are same. You all have same result. If you use this way or use this way, you get same thing. You get same thing. The formula is different, but same thing. And okay, the third way, Ex equal to M and X, and the variance of X equal to, here's M minus 1. I denote this as S squared. Then this is a modified. Modified moment method. Moment method. Okay. Moment method. Yeah, I mean moment method. Alright. Moment method. This is modified because divided by n minus 1. This one is unbiased. So this is better than those two. This one is better. This is better. If I do not have a requirement which method, then you use this one. Now I want to estimate something. If I have two parameters you need to estimate it, you use this one. Okay. But we have special case, or Ex equal to M and X, and variance X equal to this Xi minus Ex over N if Ex is given. This is the case we already know something, more than the sample date. More than the sample date. Here, when we stated the problem, we say we will find the information just by the samples. But we still have the case we already know something, and not just only have the samples. Other than the samples, if you already have the Ex value of Ex, then here you already know it, right? So you do not need use samples to approximate it. You can just use it. Then in this case, you will use this. Now, if this is given, you use this one. Use this one. This is a kind of it's a moment method. But the moment method, you already have this. So okay, we don't need this. We only need this. Yeah. That's it. Okay. So this is the case for the point estimation. All right. And the second one, we have the interval estimation. Interval estimation. We want to find interval like A and B, from A to B, so that the probability of the parameter, you put equal or doesn't matter, and because it's continuous. Actually, theta can be valued continuously in this interval. So yeah, so that this one, this probability is larger than some beta, or 1 minus alpha. If you use beta like 95%, 90%, 99%, something like that. If you write in the beta, if you in this way, in alpha way, then alpha will be like a 5%, 1%, 10%. Depend. But the meaning is the same. You use beta alpha, and both beta alpha, they are called significant level. significant level. Yeah, a little bit confused, but you should remember we want this probability large. We want this probability large, right? You estimate, you find the interval. You will say you have large chance set will be inside this interval, right? That makes sense. If you choose use a small number here, you say this probability is small. Now why do you do it, right? You want the probability large interval, right? For the interval with large probability. Okay. So the method, actually there are two methods in the textbook, also in my notes in the Blackboard. But here I just suppose you can use one method. Yeah, I also only introduce one method in the lecture. Use the method with the center limit 0. That means let z notation is z. Okay, here I just use z. Zn of x, it is summation of all those xi's minus n times the ex over the square root of n times the variance of x. This one. Then z will obey the standard normal distribution. We use this property. Use this one. We use this one. So you see this one, the summation of xi, because xi's are observed, right? So you have this value. There will be some number. You plug in the observed samples, you have sample. The summation, you have value, right? This is a value. And n is you have n samples, 100 samples, 200 samples, right? You put n here. Then you need to calculate the ex and the variance of x by formula. So this ex and the variance of x will contain the theta. Right. So z of n, you will have a number minus something contain the theta, and divided by something contain theta. So this is a kind of a fraction contain the theta. And find c from the table, so that z n smaller than c, this probability larger than, okay, you just use equal will be fine, equal beta. For example, the beta equal to, I can't remember, you need the table. Yeah, I have an example in the lecture, right? Yeah. Okay, then you have this part, this one. Then rewrite z smaller than c to be a smaller than z smaller than b. Then you are fine. Yeah. Rewrite z x c in terms like a smaller theta smaller than b. Then a, b is the result. Yeah. This interval is the result. You all know theta, the unknown parameter, will have large probability inside this interval. Alright. Yeah. Here, when we solve this, I think one thing might be useful. this one, some mass, I will say set square plus a set plus b. This one larger than 0 or smaller than 0. How to solve it? Okay, find roots. Theta 1 equal to, or theta 1 or theta 2. Here we have formula, right? There's a, okay, here if here is 1, if here is not 1, you just divide it by, okay, you put yeah, you suppose this is 1, that's simple. If this is not 1, you divide it, divide it in both sides, right? Then you still have this one, okay, so this will be 2 in denominator, right? Then here will be negative b. Okay, I still use ABC. Yeah, ABC. This is common use notation, right? ABC, the quadratic equation, right? ABC. So okay, so here will be 2a, here will be negative b, plus or minus square root b squared minus 4ac. Right? This is common use the formula. Right? We have these. You use MATLAB roots A, B, C. You run this in MATLAB, you can have these 2 roots. Yeah. In exam, you can use this, but you need to write down the code in your answer. Okay. Yeah. All right. Secondly, then we will have a theta square plus b theta plus c equal to a times theta minus theta 1 and theta minus theta 2. If theta 1, theta 2 are roots, then these 2 will be same. Okay, so this one, so we have theta minus theta 1 times theta minus theta 2 larger than 0 or smaller than 0, right? Yeah, the 2 cases depend. So this is a positive or negative. Okay, then we have 2 cases. Then there are 2 cases. Theta minus theta 1 larger than 0 or theta minus theta 1 smaller than 0. If this is larger than 0, then you can know this one gives this theta minus theta 2 larger than 0 or smaller than 0, depends on here. Right. You want this, for example, here's a positive. You want the multiplication is positive. Then this is a positive, this must be positive. The both are positive, right? If here's a smaller than 0, the first one is positive, then second must be negative. Right? So this will be negative. So depending on this. And this is also similar. From this one you will also have this. Actually you also have this, one of it. Right? Depending on here. You will check. Right? So one of these, you have this, then you have 2 cases. This one with this one, or this one with someone else. Yeah, you have 2 cases. And this one, it might be give you, this one's absolute value. That means z, I just write z for this. Z smaller than c and z larger than negative c. Okay? Yeah, the absolute value is smaller than c. That means z smaller than c and z larger than negative c. Okay, if z is a quadratic polynomial, then these two give you this one larger than a value, and this one smaller than the value. So you have these two. You have both. And each one you separate in this way. All right. Then you can solve it. Yeah. Then you can solve it. All right. Yeah, I do not list the result. You can also go over the problem in my examples. And we also have homework, right? I have homework similar with this. It is complex. A little bit complex, but it's fine, not so bad. Okay. Alright, so this is an interval estimation. And the third one, we still need to estimate a random value. This is different with the first two estimations. The first two cases, theta is a fixed number. We estimate this theta is a fixed number. Right? Yeah, you can use a different method to estimate it, but this parameter is a fixed number. Now we estimate the random value. We estimate the x itself. And here I only introduce one thing, the linear regressive method. So the thing like we know x1, x2 until xn together with y1, y2 to yn, and also we have a y0. We want x0 here. What it is. All right. Then we find we have formula. We have several different two way or three ways. Yeah. The thing is, so we step 1, find A and B from yi equal to axi plus b. From this, you can solve here. I will be run from 1 to n. You can solve it using MATLAB, or formula. I can't remember. It's something like A should be covariance between x and y over the variance or square root of variance of y, x or y. I can't remember. You check the notes. All right, something like that. And do we have square root? Yeah, I cannot remember the formula. Yeah, you solve this. Then you have a equal to something, and b will equal to b. Just this one. B is b will be y. You do you take the mean n of y minus a times the mean n of x. This is b. After you get y, you get b. You can have after you get a, you can have y. You can get b. B just this is y minus ax. But y use average value, x use average value. So b you can obtain just by this. But a you need a covariance between x, y over something. Yeah, you check the formula in the notes. All right, in the lecture. You can also find this from textbook. So, and then step 2. x0, right? You want to find x0. x0, it is just a times y0 plus b. That's it. Okay. Yeah. And Yeah, you can verify that will be y is here, x here. You can put some point here, and this one actually it's a straight line, right? Y equal to ax plus b is straight line. Oh, x. I'm sorry. I want to find x. This is ay. This is x. So here will be this is y. This is x. Okay. Yeah, a little bit confused. I know some of you guys during your homework is also confused about it. Yeah, me too. Yeah, but this one is good. Now it's good. Let me see. We want to find x, so x should be obtained from y, right? So this is good. Yx should equal to ay plus b. We want to find x, so start from y to get x. So the formula is this one. We want to solve this. So this you can use a MATLAB way. You write the coefficient matrix A, then the A prime times x, and here's A prime A with the inverse. Right? Just run this, you can have the answer. This way is quite simple. You can also find all these covariance, variance, mean, then plug in this formula, you get A and B. They are same. They will have same answer. Okay, so this is the estimation. Then for the let me see, for the statistic part, I think I only have these three, right? Estimations. Okay, and then we go to the stochastic part. Stochastic process. Actually, here we already have some very basic things. The first one is the definition. And we should know the type of process. We have two features about the type. One is the type, continuous or discrete, right? And value, also continuous value or discrete value. So you have four cases, right? Continuous time with continuous value, continuous time with discrete time value, discrete time with continuous value, discrete time with discrete time value, discrete value, discrete time, discrete time. Yeah. Okay. So four cases. And then second one, we have some concept. We should know the IID process. We have the stationary process. And wide sense stationary process. ID, that means all these, you can just think this is a symbol chain. Okay. You have one random variable, then you have a sequence of the symbols, then that is ID. For stationary, that will be more complex. You need all the joint distribution. They satisfy some condition, right? Yeah, that's too complex. I do not state it here. You can check the material we studied. And then wide sense stationary process. This one we can describe by that. It's the mean. Oh, before that I need a third one. Actually, we need this one firstly. So this is average values. values of a process. So like this process is x of something. Here might be t and might be n. Might be t, might be n, depending on the time is continuous or discrete time. Then we can have mu x dot means the time, discrete or continuous. We have the variance of x, or for simple, you can write in this way. Right. And then you have the cx. Okay, this is also time. Okay, I write n and m, or cx t and I say tau. Right. And then rx n and m, or rx t and tau. So you should know how to calculate this one. Right? Actually, this part is a non-new thing. We know how to calculate mean, how to calculate variance, how to calculate the covariance, how to calculate the correlation, right? For any random variable. Now for a random process, we still know how to calculate it, because for fixed n and m, they are just like this one. It is actually it is a covariance of x of n and x of n plus m. Or if it is a continuous case, where be x of t and x of t plus tau, right? Yeah. So like this. Then you calculate. Just use the early knowledge. You can know how to calculate that. Okay. Then after this one, you know what is Y-sense process. It will be this one. This one, the mean value will be a constant, independent with the time. Alright, independent with time, no matter the time is continuous or discrete. Right. And the second is the cx of I say n m equal to cx this one is 0 m, or cx t tau equal to cx 0 tau. So satisfy these two conditions, it is Y-sense process, Y-sense stationary process. So for this part, I hope you know how to determine whether it is Y-sense process. So actually it is a calculation, right? You need how to calculate. After calculate, you will see, okay, the mean is constant. Alright, good. If the cx, the correlation, covariance, and not correlation is R. C is a covariance. Whether the covariance satisfy this one, that means the covariance value only depending on m, no matter what is n. Independent with n or t. Right. In this way is independent with n. This way is independent with t. So if it is independent with n or t, together with the mean is constant, then it is Y-sense stationary. Right. So yeah, for stochastic process part, we only have these three topic. You should know what is the type. You should know how to calculate the average stuffs, and then you need to determine whether the process is ID or stationary or Y-sense process. Yeah. And what else? Yeah, things like that. Then okay, so this is a stochastic process. Okay, for the review, I just want to give you this. For early part, I said you just go back to midterm 1 and 2. All right. What else I want to say? Okay, that's all for the review. And then here I just hope you all have a good final exam. Okay, bye bye. Have a good weekend.